Alright, so in section 4, we looked extensively at solving quadratic equations. And moving on from here, really the biggest thing that's going to come from section 4 that we're going to apply into section 5 will mainly be the quadratic equation, because the quadratic equation, it's not always the easiest way to solve the equation, but it is a way that is not too complicated and it works all the time. Some equations are very easily factorable, and obviously if things are perfect squares or conjugates like we've done before, it's very simple. The quadratic formula would really be too much work for that, or it'd be too much unnecessary work. But the quadratic formula is not a ton of arithmetic, and it gets us the solution every time, whether it's a perfect square, the product of conjugates, whether it's something that's factorable, or whether it's something that is not factorable. That works all the time. Going into section 5, what we're going to start focusing on now is actually graphing these. And the first way we're going to look at doing that is graphing them from standard form. Now we're starting with standard form because that's a form you should be familiar with. It's the form that we have used for quadratic equations for all of section 4 and for some other things we've done in other sections. And so here is standard form. We have our degrees in descending order. We have second degree, first degree, 0 degree. It's equal to f of x. So whatever we plug in, we get an output, and those would be what we graph. Now, we're not going to do this by just picking random numbers and plugging it in. That's not always the best way to do it, because we might not pick numbers that are very well suited for the specific function. There'd be a little bit too much work going into that, but there are some features that we can look for and find very easily that we can use to graph this without doing a whole lot of work. So here's the features we're going to look for. We're going to look for the opening, whether the parabola is going up or whether the parabola is going down. So, is it pointing up? Is it pointing down? The axis of symmetry, where's the line that goes down the center of it that separates the one side from the other. And the axis of symmetry is going to be really helpful in finding the vertex as well. And the vertex will be this exact point right here. We're also going to look for the x-intercepts, also known as the solutions, where it crosses the x-axis. And then we're also going to look for the y-intercept, where it crosses the y-axis. So the first thing we're going to look for is whether it's opening up or down. And this is extremely easy. All we're going to do is look, is A, so the A term, in this case it's 3, is A positive or is A negative? I'm going to circle that. Well, this is a positive 3. Since it is a positive 3, this parabola is going to be opening up. No arithmetic involved in this step at all. Now we know that it's going to look something like this. Now we don't know where it's going to cross the x-axis. We don't know where the vertex or the axis of symmetry is going to be. But we do at least know that it's going to be opening up. We know that it's not going to be opening down. So it won't look like this. It's going to look like this one. Okay, so the next thing we're going to look for is that axis of symmetry. And this is going to begin to give us an idea of where at on the infinitely large coordinate plane this specific function is. And here's our formula for that. So you're going to want to write this down. You're going to want to take note of that. This is the formula we're going to use to find the axis of symmetry. It's actually from the quadratic formula, so if it looks familiar, that's why. But all we'll do is we'll take B, which is 2, so I'm kind of making note of that. B is 2. We're also going to need A. A is 3. And we're going to plug that into this formula. So negative B, so the opposite of B. B is positive 2, so we'll plug in negative 2, over 2 times A, which is 3. 2 times 3 is 6, so we have negative 2 over 6, which is just negative 1/3. So there's our axis of symmetry. So what that means, if we think about the actual graph, we have a coordinate plane here. Let's say we have 1, 2, 3, 1, 2, 3. That means that our vertex is going to be somewhere right in here. The center of the parabola would come through here. Right through here, around negative 1/3 somewhere. Now, vertically, no idea where but somewhere on this line is where the vertex will be. That's where the center of it will be. So let's now use this to help us find the vertex. Now the way that we do that is just simply plugging the axis of symmetry, that negative 1/3 we just found, into the function to give us the output. This is our input. It's the x coordinate where the vertex is going to be because it's the axis of symmetry. Now we're just going to plug it in so that we can find that output, which will tell us where the vertex is precisely. So we'll do negative 1/3. Oh, sorry, let me back up. Put that in wrong. 3 times negative 1/3 squared plus 2 times negative 1/3 minus 1. We'll simplify this. That'll give us our output, which will give us the vertex. So negative 1/3 squared is 1/9. So we have 3 times 9. 2 times negative 1/3 is negative 2/3, and then minus 1. Alright, so let's keep simplifying this a little bit further. 3 times 1/9 is 3/9, which is actually just 1/3. So we're going to say 1/3 minus 2/3, and I'm going to change this 1 to a 3/3. That way everything is thirds. So we do 1/3 minus 2/3 minus 3/3. So 1 minus 2 minus 3 is negative 4. So we have negative 4/3. That's the output for our vertex. So our vertex here is going to be negative 1/3, negative 4/3. And this is a coordinate. So this is our vertex. And if we think about the coordinate plane, what that means is when we graph this, so 1, 2, 3, I give some marks for y as well. Negative 1/3. Negative 1/3 is about right here. Negative 4/3 is just a little bit past negative 1, so negative 3/3 would be here, and then we go a third past that. So about right there is where our vertex would be. Let's see if I can mark that somewhere. About right there is where the vertex would be. Now, so what we know so far is that it's opening up, and we know the vertex is here. So at this point we can kind of give an estimate. Maybe it looks a little something like that. But what we don't know yet, we still don't know where it's going to cross the x-axis, those points. Don't know that yet. So this may be accurate, this may not be accurate. It might actually look maybe something more like this, or maybe even wider than that. We don't know precisely, but we do know the vertex is right here, and we do know that it is going to open up. But other than that, there's still some things we don't know, so we need to find the rest of that information. So let's find the x-intercepts. And this step is one that's going to be really familiar. This is what we focused on all of section 4. And so even if, and I'm going to use the quadratic formula to solve this, so it's a good review. If some things were a little unfamiliar with you or you're still a little confused on the quadratic formula. So the first thing I'll do is write the formula out. Negative b plus or minus the square root of b squared minus 4ac over 2a. So I want to just identify my a, b, and c to make this a little simpler. A is 3, b is 2, c is negative 1. I'm just getting that from here. And again, it's equal to 0. If something else was over here, we'd need to move it so that it was equal to 0, or so that it is equal to 0. Function. We're working with a function this time, so really it's equal to f of x. We're setting it equal to 0 because 0 is the output on the x-axis. If we don't go up or down, that's 0 movement, so 0 is our output. So let's plug all this in to the formula. So the opposite of b, that's going to be, change colors, it's going to be negative 2 plus or minus the square root of b squared, so 2 squared, which is 4, minus 4 times a times c over 2a, so over 6. Alright, so we've got, I'm going to come this way with it. We've got negative 2 plus or minus the square root of 4 minus 4 times, negative 4 times 3 is negative 12 times negative 1 is positive 12 over 6. Alright, we'll keep simplifying this. Negative 2 plus or minus the square root of 16 over 6. Alright, let's keep working here. Negative 2 plus or minus square root of 16, that's a perfect square. So 4 over 6. Now we're going to take this and simplify this one step further using the plus and minus so that we can get the two different solutions to this. Alright, so I've just deleted some stuff so that I have some space to work up here. It's kind of running out of room. A lot of these steps you could kind of possibly do in your head, maybe go straight from here to here. I just wanted to show every step for some of you that might still be a little confused on the quadratic formula. So we're going to do negative 2 plus 4 over 6, and we're also going to do negative 2 minus 4 over 6. We're going to simplify both of these, and this is going to give us the two different solutions we have. So negative 2 plus 4, that is going to be 2 over 6, which is 1/3. So one of our solutions is going to be 1/3 0. That's the coordinate, because it's on the x-axis. That's why that other coordinate is 0. Negative 2 minus 4, that's negative 6 over 6, which is negative 1. So our other solution, our other x-intercept, is negative 1, 0. Now we can use this information to take this graph even a little bit further. So I'm going to erase some of this so I can actually graph this using the information that we have up to this point. So what we know so far is that it's opening upward. We know that the vertex is at negative 1/3, negative 4/3. So again, that's about right here. Maybe that's not perfect, but it's close enough. We know it's at negative 1/3, negative 4/3. We know it's opening up, but now we also know that it's going to cross at negative 1, 0. So if this was negative 1/3, we'll call 1, negative 1 right there, and 1/3, 0. So just barely past, not quite to 1. Again, we also know it's opening up, and it's got to go through those points. So we're getting a better picture of what this graph looks like. The only way that we can, the only other thing that we're going to add to this as well is the y-intercept. Now, the y-intercept is really simple. This is another step that doesn't really take any arithmetic. It's just whatever c is. In this case, it's negative 1. So negative 1 is where it's going to cross the y-axis. And if we look back here, that's, about negative 1 where it crossed the y-axis. Remember, we were, this is negative 4/3 where the vertex is, so just a little bit above that is about negative 1. Maybe it should have come a little more like that before it came up, so the other side would kind of need to mirror that as well. But again, this isn't perfect. We're just using some of the features to get a very close estimate of what the graph is going to look like.